Yeah, hi everyone. Appreciate you coming to this talk. I know we had another LLM evaluation talk just now, which I also was attending for a bit. I'll be talking about some things that'll really complement some talks that I saw had happened yesterday or this morning. This is specifically about production, and there might be some overlap, but I think the talks complement each other and don't fully overlap. A little bit about myself. My name is Susan. I'm a principal data scientist at Elastic, so we make tools like Elasticsearch and Kibana. I've spoken at a lot of PyCons around the world and other conferences too. I'm also the author of Machine Learning Interviews, which was published by O'Reilly. So great to meet you all. I actually just moved to the greater Boston area, to Natick from Toronto in Canada earlier this year. And when people meet me, they're like, "Oh, did you move to Boston?" And I'm like, "Depends on where you are." If they are not from Boston, then I'll say I moved to Boston because they don't know where Natick is. But people here, they'll say, "Oh, did you move to like Brookline is not Boston, Cambridge is not Boston," things like that. I'm still getting used to it, but great to be here. My first in-person conference again after moving here. So what we're going to talk about today are a little bit of stage setting about what the agents my team and I have built, just to set the stage and try to make it so that it's more applicable to your own situation, as well as the steps involved in creating like an evaluation harness for production or offline evaluation for product development. So some repeatable steps, creating test data sets, setting up tracing and evaluation, doing offline evaluations or online evaluations for production, as well as how you continue to improve the product. Let's see. I think the slides are, okay, good, we're back. So to set the stage about where my team works, this is not to talk about Elasticsearch, but just to set the stage a little bit. If you've interacted with a lot of web apps, you might have interacted with Elasticsearch as a web store. So for example, if you've used Wikipedia or let's say Stack Overflow and so on, like they might use Elasticsearch to implement search, or like they store their data in it. Elasticsearch or other forks of Elasticsearch like OpenSearch or other technologies enable you to retrieve these information really quickly. That's why a lot of applications will use Elasticsearch or similar technologies in the background. So for example, GitHub or the Tinder search and recommendations are using Elasticsearch. But again, I'm just setting the stage because we have the Elasticsearch kind of data store devs, and I'm not one of those. I'm not writing like low-level C++ or whatnot. I am actually doing data science development on top of that. So within Elastic, we also have, just like same old data science and machine learning teams that you might have at other tech companies. So this is where my perspective is. I'm building just same types of products as you all might be, like chatbots or kind of general building blocks or AI agents that might help cybersecurity analysts discover like novel attacks, right? Those are things that my team and I are building and that you might be interested in as well. So those are in production. We just happen to use Elasticsearch because we are within Elasticsearch. So people use Elastic, of course, like as a data store. They can store like all their kind of products or whatnot for their web search. They can store like logs or, like let's say you're logging your servers and monitoring your like cloud deployments. You can ingest the logs and they just come in. So they can be for anything, right? Like again, products, Wikipedia or Tinder for user matching, so on and so forth. So these are the types of things that my team and I built. So one is called attack discovery. It's given these monitoring logs, use agentic AI to help the user automatically extract potential cyber attacks. So here you might see a summary, which is, let's say, given some of these logs from this user, they think that this attack, Linux backdoor, is happening. And other more general use cases we have are just like, chatbots that, because people have their proprietary data in Elastic, they might use Elastic to build like support bots or, using RAG with Elastic to build whatever other bots they have. So we also provide this functionality, and then we have to evaluate this, and this is all in production with enterprise users. So that's the kind of angle where I'm sharing this from. So before we make any changes to our agentic AI in production, we have to ask, how do we estimate the quality of the responses if we make any changes? So you might have heard other talks already that's been covered, like they might have different types of tools for your AI agents that pull, that are called when the user is interacting with the agentic AI. Let's say you're making some changes to those tools, or let's say you're making some changes to system prompts or whatever that is in your AI agents. How do you guarantee that the change is not an improvement and it's not going to cause like suddenly the agentic AI is going to behave totally differently? You want to test that before you deploy it to production. And we also want to test these results in a repeatable manner. So I'm going to share some of the tools we use internally. So there are different repeatable steps, and I've had to repeat this for different projects. So let's say we had the cybersecurity AI agents, so we have to create a data set for that. Let's say for a chatbot creation using agentic AI, you'd have to create another data set for that kind of use case. So at first it's pretty daunting, like, oh, you have to create a labeled data set and label it. It's so time consuming, but then as we repeated this process, it became more and more kind of simple. Like you can kind of abstract it down to a few steps. And it doesn't have to be perfect initially. So the main steps I would say are data set creation, label them a bit, have like your subject matter experts coming with you on this, as another evaluation talk has mentioned, and develop different types of evaluators that you want to kind of really make sure that your AI agents are performing like as expected. And then of course you want to do it continuously and not just before you deploy it one time. And you want to keep monitoring that. And this will be possible with some of the tracing that I'll cover. So first, test data set. Depending on your application, ideally a realistic looking data set, you will have to do some manual labeling. So here in the cybersecurity use case, right, it's a field where you don't really have a lot of publicly available labeled data specifically for our use case at least. Like we can't just access it. Like depending on your field, you might find have a hard time getting like publicly available open source data set. So I think this is like pretty applicable to that kind of field, which is you will need to do some manual labeling and include positive and negative cases. So in my example where we have the agentic AI that's given some logs, it analyzes the logs and then sees if there is potentially a cyber attack. Like what are the expected cyber attacks, as well as when the activity is just benign, provide examples of that so the AI agents are not constantly false positiving. So this is important to think about. In this example, which is the just enterprise data chatbot, which might be a more general use case, right? Like so pulling up support documents or whatnot. I've actually recently used pretty good chatbots from 2 financial institutions. I don't want to like name them, and I don't think they're necessarily customers of ours, but I was actually impressed with, they actually pulled up some documents that I didn't find myself. So maybe they're getting better and better, but some of them are not as good. You know, just the good ones are good. The bad ones are noticeably not as good. This kind of data chatbot, you probably have seen a lot of them. Again, vary in quality. We will have different types of data sets that might mimic a question and an answer. Actually, I'll provide a better example here. Here is one specifically for, this is just an example, like depending on the situation, but this one is, let's say you have some internal documentation, hypothetically, and then the user is asking like, I'm trying to do this, what should it respond? So you'll have an expected response which assumes that it's pulled from the right documentation and then summarize the results based on the user query. So this will be one of your examples of labeled data, but when I started working on this, I really felt that this is really hard to say. Each time you generate a response, that second good enough response is always different, right? Like, and I think as I've been in data science and machine learning for a while now, when we're working with more traditional algorithms, the expected response or the label should be basically like 0 or 1, or the category is like this or that, right? Dog or cat, or, just for example. But after working on LLM evals for a longer time, I realized that like there is some of that ambiguity involved. There are other ways to make sure that this ambiguity is resolved during your evaluations. But just for now, it's just like assuming that it's good enough, let's say. So when you're creating a data set, it doesn't have to be perfect, and it doesn't have to mean that every time your AI agent in production, let's say the user asks this question, it doesn't have to answer exactly the same way. It has to be just like good enough for now, and then moving on to create the rest of the data set. So for security, I mentioned two different types, like the chatbots as well as a security use case, to make it more applicable for like, more general, as well as let's say you're in healthcare or security or something like that. You'll need to put in a bit more effort. We actually had a cybersecurity expert on our team they set up like VMs, and then they try to extract credentials or things like that. So various attack scenarios which generated logs using observability, which the agentic AI is supposed to catch. So with that data set, we created a few. You can see that this is not a lot. It has 10 different attack scenarios, but of course, it wouldn't cover every single attack under the sun, but just like some major ones we expect the agent needs to catch. And of course, like benign scenarios as well. So you might see that maybe compared to when a few years ago, before doing a lot of LLM evals, we'd want to evaluate with like maybe millions of records. Our team has other models, which are just like XGBoost models or whatnot. The kind of test sets are like millions of records, right? Like it might not be possible initially with your LLM data set, but it's not just our team, but other teams I've read in industry are also kind of like you manually label at least a small amount, let's say 10, 20, or 50 to 100 for starters. We actually started with using Excel copy and paste, which actually was the case for other traditional models too, right? Like you might have a simple evaluation, you have not as many days test data records, but then you can eventually scale it up as you go. But just for starters, label at least some of the cases that you really need your AI application to get right. So the next is tracing, which is really important for us to be able to run evaluations in not just development, but also production. So there's a lot of tools with Python packages or SDKs or wrappers that are available. You might, depending on your tech stack, you might use other types, like TypeScript or other things, but I would say the majority of these, they have support for at least Python or other kind of general like web frameworks. So there's Langsmith, Phoenix, which we both use. I don't want to speak for all of Elastic because we actually have a lot of teams that are working on AI, but the ones I've had personal experience with would be Langsmith and Phoenix. There's also LangFuse. MLflow can also do this, or people might already have observability, like other types of observability that isn't necessarily focused on Gen AI, but you can still make do with the traces as long as you're kind of instrumenting them in your own code. So it might be easier, like for you, depending on where you already have your agents defined, because we were already in the Langsmith kind of Lang chain ecosystem, which is LangChain, the company, which makes LangChain, LangSmith, and LangGraph, which is their agentic AI framework. So it was easier for us to first start with LangSmith, but then, as things mature, we are looking into try to consolidate multiple teams into one framework, which may or may not be LangSmith. So I don't want to speak for everyone. So this is an example of the LangGraph agent. I just found a default image from the LangChain/LangGraph documentation, but you might have heard from other talks, like let's say, tool calls and like traditional downsides of just using LLM would be that maybe it doesn't have access to real-time data, or it doesn't have access to your proprietary data or your customer database, which is essential for like these support chatbots or specific use chatbots as well. So using agents will enable you to define more behaviors like calling queries or RAG to your proprietary data or customer database and so on. So with each step, right, because the tools, there's a lot of tools. If for one question the user asks a question that doesn't require anything at all, it might not even call any of the tools. But if they ask a question which does involve querying a database of your internal customers in order to answer their specific question, then it'll call the tool. So we need to trace it in the sense of like every time it calls a tool, every time it has like a logic that, because it's more complicated than just like one question, one answer, right? Like it might be routed to different system prompts. You might have multi-agents set up. It might route to different agents, which then decide different things, right? So we need to trace every single step of the way, like whether they called this agent, whether it called RAG or not, what it did in RAG, right? So using tools like this, we're able to trace every time a user asks something and gets an answer. And with agentic AI, it's really complex because, as I mentioned, there's all sorts of like branching involved and decision making that it's making. And if you don't know what it's doing under the hood, you can't like evaluate it. If you're not tracking this, you're just guessing, or all you can see is like a black box instead. But here you're able to see, oh, it's using RAG, it's using vector search and for this problem. So this is another tool, which is Phoenix, and they have similar user interface. This can all be set up with, actually it's pretty automatic. So for our example, I'm not sure about other examples, like when we have created the agents, we are using LangGraph. So we just need to kind of like import LangSmith and just like actually, I think it's like a one-liner or something. It'll automatically kind of send all the traces up to LangSmith. So for you, it might not be that complicated depending on the situation, or you might have to manually write like, oh, when it's doing RAG, you have to like, put the trace up. So that's just one example, but because we have it, the tracing SDKs make it pretty easy for you to send up all that decision making for your agentic applications. And also, because I mentioned data sets, right? Like you have like the questions and the answers, and like how are you going to store those data sets? Like one way you can do it is just like kind of automatically extracting the questions and answers, but some of the tracing tools will allow you to add to data set through the UI, which does make things a bit easier. So this is one of the examples, or you might have to have an automated way to, to add the data sets as well. So finally, you will have a data set with your expected questions and answers, and ideally with a subject matter expert's input. It doesn't have to be a ton of records. It just needs to be at least like your critical questions and answers, right? For, let's say for a support bot, like what are things it must not get wrong? And this might have to be in collaboration with like product in your team. They might not be able to come up with everything, but you need to come up with at least like something to get started. So there's no kind of decision paralysis. And if you're not confident to deploy to production, it's okay, right? At least you have something to start with. So next, we have the metrics. So I mentioned that we have the data sets of expected behavior which have the inputs of your subject matter experts as well as data science experts. And actually, we found in our company that the cybersecurity subject matter experts are, of course, also interested in like LLMs and like agentic AI themselves. So, I mean, like we become frequent collaborators, and then they are able to make a lot of really great inputs themselves as well. So that has been something that's emerged in at least my team. So that's been pretty good. And next we talked about, how you're able to capture all of those traces. And if you don't capture them, it's basically a black box. You don't know if your AI agents have pulled this tool, like run this query, right? You need to know exactly what it's doing. So next would be something that's pretty similar to our traditional data science or ML, right? You might want to define some metrics. And these could be some things like precision recall, which are also common in other data science projects. But I would say this is too simplified for LLM-driven applications, because as we saw earlier, that the expected responses are pretty ambiguous. Like, what is a response that's similar enough to this former response? Like, the wording could be completely different, but convey the same information. So you want to have a combination of ambiguous evaluations or qualitative, whatever you want to call it, as well as some things that you can put as like more structured, you could say. So things like semantic similarity is one of the ways that you could do that. But I find that semantic similarity is like less useful for really like long paragraphs. They're more useful for like terms or like some small phrases, key phrases. Factuality, which is custom, some custom definitions that you can put down. I'll cover this a bit more. So you don't want your AI application to hallucinate like a product ID or fake product that you don't have, or like a fake treatment that doesn't exist, right? So a lot of this is going to be custom. So here we just have like how we are evaluating factuality. So this could be like extracting categories that the AI application has output, like, oh, we found these attacks. And we know that given these logs, these are the attack characteristics, and do they match? So we're actually using explicit matching. We're not using LLM-as-Judge for things that are extremely important, like this. So you could, for your case, it could be like product ID or things like that. Here are some examples of precision recall. We might match some IDs. For similarity, we use BERT score in this case, but not necessarily for every other case. It depends on the situation. Factuality, so are some of the key characteristics present. So we're actually just using Python like to write this. And some of the attack chains consistency, which is just like checking if we're false positive, there's false positives, or they're kind of over or under reporting of attack. And this is going to be different for your enterprise chatbot example, which does highlight that there's no one size fits all, which is, this might be, oh, you're checking if the RAG is accurate. So this is like a whole other kind of domain of like, because this talk is not covering RAG, right? But there's various ways of making sure that if the agent is calling any sort of RAG tool, that it's accurate. So you might have like a small like independent evaluation for that tool. And then this is more like for the end-to-end evaluations. Factuality, so let's say the key facts, are they present, and so on and so forth. The last one I did highlight, so ESQL validation. So this is really interesting because our enterprise chatbot needs to answer Elasticsearch has domain-specific languages. So one of them is called ESQL. There's others like KQL and Painless Script, which people can use to query Elasticsearch. So let's say you're, okay, this is just very specific. So we actually have to call a tool that is the ESQL linter or things like that. I think for other companies, it might not be as specific. Like this is basically our own language, right? Let's say your company has your own query language or your own custom programming language, and you need your own chatbot to be able to generate these queries like specifically. So it is a challenge, but we need to call it to just like validate that the query language is correct. So let's say your chatbot is generating, for example, JSON, right? You might need to have your agent call a tool that independently validates that the JSON output is absolutely correct, things like that. Though we have found that for JSON or things like that, some of the LLMs out of the box, the newer ones, are able to. They're pretty good actually at telling if this JSON object is actually completely correct, but you don't want to leave it up to chance depending on the situation. So there's no one size fits all. I showed here that we have two different use cases as an example, and they are using different metrics. So you want to work with subject matter experts, or if you're the subject matter expert, that's good too. Get feedback from users, or if you haven't released it to production, kind of getting a good proxy from your users. Your evaluation data set doesn't need to be perfect. Actually, we kind of psychologically struggle with this a little bit in the data science team because we want, perfect labels, right? But I guess like after doing this a few times over different projects, it's kind of like you want to compare it to human outputs, like a human summary. If a human looked at these logs and they thought this was the cyber attack that's happening, is that good enough? Like maybe the human's wrong sometimes, right? Like that is also possible. So just good enough for starters. Let's see. So, and of course, like I think, yeah, like there's some situations where you might not have defined what you want the outcome to, what's the actual like validation, whether it's performing well or not. You don't want to have no definition of like, this is what it means to make this change and improve. I think someone mentioned it in another talk, which is like hypothesizing after you see the results. I forgot what that acronym was, but just like you want to just like define from a, let's say, product perspective, like what is an improvement, right? Does it at least achieve baseline level, right? This is similar to when we have like traditional ML models in production. So just bringing that up because it's good to define it beforehand. So the next I'll cover various evaluation methods. So there's going to be LLM-as-a-Judge. I'm going to cover a little bit of what we found using this in production. So one of the cases is you just have the summary of LLM-as-a-Judge is just like you're asking one LLM if this output is good, right, of another LLM. So you have like your chatbot, let's say, it generated a response. You have another evaluator LLM to say, ask it, did it hallucinate? And it tells you yes or no. This is very, very simple simplified to explain the example. And if you're doing this kind of offline for your evaluations for improving your product before you deploy any changes, this might be the example here, like our chatbot needs to generate ESQL query. So we have like a use case that is complicated, like it's asking, the user is asking, generate a query that will do this and this. We have an example like no good answer, and then you have, let's say, your experiments, like you're changing the tools of the agents, or you're changing some order of the agent workflow, things like that. So you'll have like the changed version and then the new response, and then you'll have your LLM-as-a-Judge just to ask it, are these responses similar? If you have the evaluation for this question that you think that it must get right. This is not always available because you'll always have cases where you don't have the question and answer in your data set. So in that case, it would just be like this. So there's no response to compare it to. So there's two types, right? You can do for offline evals, which is like not in production, you can compare it to your kind of correct answer or your golden data set. Or for just using LLM-as-Judge without comparing, then you can do it for both. When it's in production, you can ask like separately if the response is good enough or things like that before displaying it to the user. So this is one of the things. Okay, well, I'll cover that in a bit, actually, the workflow. So these are some examples of LLM-as-a-Judge rubrics. So these are some things that might overlap with your like Python, or you want to use code to actually answer these questions. That's fine too. This was a really early version of our LLM-as-a-Judge rubric, so not all of them are still the same. But let's say you want to evaluate the fields in the submission. Do they match, or is the explanation good enough, or things like that. But more specific, not just like, oh, is it hallucinating, or is it good enough? There are some other things you might want to do. So for example, they are useful for, like, let's say you're more like a marketing chatbot or something, right? You might want to have the LLM-as-a-Judge do something like, is the tone like matching, or is it coherent, or style, things like that. These are things that are really difficult to use code-based, like Python matching or whatnot, like regex, right? Like you can't really like match tone with that. So I think LLM-as-a-Judge is good for these more ambiguous cases, and as long as it's good enough, right? You can't always be perfect, like your LLM is not perfectly knowing your style all the time, but good enough, or catch the cases where it should not be displayed to the user, period. Like if you can do that, that's a win. So it can judge some of these things like correctness or completeness. For if you're using like a reasoning model, you can have it explain what the rationale is if you want in the back end, if you're tracing that. And it's easy to kind of scale this because you don't have to write a custom evaluation like matching for everyone, for every use case. Of course, there's cons. Might not be granular enough. There might be crucial differences that the LLM can't identify, or it's too ambiguous. The key is that, like, for things that can be scaled, excuse me. Let's see. Yeah, you want to try to find the right balance between what you want to use, so-called like hard-coded matching versus LLM-as-a-Judge. There is something I do want to point out, which is potentially biased towards models from the same family. Let's say you're using Llama to generate your chatbot, and you're using Llama to kind of evaluate like Llama results versus other models. Like it might think that the Llama model is better because the training data distribution. So this is something that we found, or like we also, there's a paper that I'm putting up here that we found as well. Or that we use to shape our own evaluations based on papers like this, which they also kind of, I guess, acknowledge that it could cause like inflated results for the same family of models. So just as long as you keep that in mind. So the other evaluations are crucial points you can't let LLM-as-a-Judge get wrong. So you can use Python or TypeScript, less ambiguity, but it's less scalable because you have to, well, you can generate the code too and test it, but just like the fact that you have to run each of them might be slower for runtime if you're trying to run everything during generation. Of course, like some of this you can, what I like to think about it is when you're running things, when you're doing something that's live, for the user, let me see if I have a diagram later, but there's like a subset, which is like you want to prevent some of the bad results from showing to the user, so that's like a smaller subset. You can't possibly run every single type of guardrail or whatever during runtime for the user because it would slow down the generation. But when you're doing it offline, for just like product purposes or testing yourself, like you can run all sorts of things, right? So you just need to keep that balance. So here, for the rules-based evaluation, I would say you can use the custom, a lot of custom code to do evaluations for those things that you're not using LLM-as-a-Judge, but actually for LLM-as-a-Judge, you can use let's say, schemas or kind of, I guess, validation that you can pass into some Gen AI frameworks. I don't know if they exist in every other framework, but at least I know, like Langsmith and Langchain, they can check, like, let's say, a JSON schema or have a data like schema. You're able to do that as well. So if you want to kind of, if you're unable to maintain that amount, then you might try to put it all in once in the LLM-as-Judge as well. So calibrate your evaluators, like whether they agree with the human evaluators and your target behavior. I have a quote from my friend Eugene Yan, who writes a really good data science blog. He says, it should be consistent, and there are some tips there too. And of course, we have human in the loop too, which is you would want to take a look at the outputs of your agentic AI, as well as have them provide the expert review, and for creating the data set too. But I'm not going to cover this too much because it is important to do, and there is a lot of, I think there might be other talks that have covered it. But in our case, we have collaborated with some security subject matter experts. I'm not a security domain expert, right? So we have to work together to achieve the evaluations. Doing a quick time check?
Yeah. So we have 5 minutes.
Okay.
Yeah.
Okay, so here I have the example of the online guardrails, which is during production. This is a simple diagram, but just like, I think there's other like safety and guardrail talks that might cover more details, but when you're doing it in production, we will have like a regeneration loop, which is if we have the guardrails or various rules that find that the initial generation is not good enough, we will attempt to regenerate an answer or do some other things before displaying to the user. So this is important, especially if you don't want your agentic AI to accidentally, display wrong information, or there's lots of other problems apart from wrong information, right? Like, but just catch that. And there's a lot of built-in tools or guardrail tools that can help do that. So I think I'll have a subset of that during online, and then when you're just developing this offline, then you can run much more guardrails. So tying it together, how do we kind of talk about this to, let's say, product people or our team and decide for release? So we do have the raw scores that I mentioned. We'll have defined metrics, and then we will roll up the scores potentially into one score, but we also want to display all this as well, because there are the downsides, which are if you roll it up into one score, it might be oversimplified. So this just depends on the situation, and it's more like a communication exercise between your internal teams, like technical and product, or a mixture of both. So we'll have the evaluations, and we'll iterate on the results because we have the tracing. So before we push things to production, we'll do these evaluations. Often we'll have qualitative evaluations, which is like human in the loop, which is we'll also test it ourselves, like manually, like type it, like have a natural conversation with it, with the changes, try to see if that kind of passes like your test. And then after pushing it to production, we'll also have monitoring to see, the results and if they're being generated, if they're improving or at least the same. And I mentioned creating the data set initially with less examples, but as you have more production cases, you could actually bring in much more examples of what your users are asking into that data set that you don't want your agentic AI to get wrong. So this is a kind of iteration, and we can have that. And you can also have some lower tech kind of things like copy pasting to Excel to share and things like that. So we also do that, and other people also report having to do that as well. So it is all like all that process together. So I do want to shout out some folks on my team that made these features and work possible, even though I happen to be one presenting them. And yeah, thank you very much.
Now we have like a 30-minute break, so we're technically at the time for the talk, but because we're at a break, I guess you feel free to stay and ask questions if you want to answer. Yeah.
Okay. Yeah. Yes.
So a lot of these evaluations I've seen so far, they focus on one question, one answer. And I'm wondering what people do when you have a long thread of conversations with you're trying to triage with the pilot a complex problem, for example, customer service. And to be able to evaluate the quality of the next response, you need to feed the entire thread into the system. So how would you do that?
Yeah, we could have a data set, like we have tested with maybe like three like responses to 5, like just interactions and responses, and kind of use that as part of the data set. But then I think there's also ways to boil that down, because when the conversations gets long, like some LLMs or in some applications, you'll actually start to summarize the conversation because you don't have enough context to pass in the entire prior answers. So then you can use the summary of the prior conversations as kind of like the input, like the summary plus the new question, and then use that as a input and output. So it's not perfect, but still the things like, the correct IDs or the correct answers should still be applicable, even if there is a longer conversation thread, right? You can boil it down to that, or use more qualitative methods, like kind of inspecting the traces. Because we actually do have to, despite like a lot of this seeming like it's super totally automated, we actually do have to make use of the trace UI quite often. Like we're going and like kind of expanding it and looking to see if it called the tool or not. So I guess a mixture of those things.
And if you have like an application that's serving like a large amount of users, what are the ways to aggregate the traces across many conversations to get some high-level view?
That's a good question. I think we have a lot of, lots of conversations, and I would say they're currently just traced like individually. Like we're not aggregating them until later, like in the kind of raw, like observability or kind of like the trace. I guess we're not doing any, for the raw trace, we haven't like aggregated them. I guess we only do that when we're running evaluations.
So I was curious if you or any of your coworkers have experimented with using Elasticsearch built-ins for evaluation. So for example, using indexes to persist the outputs of experiments, and then using something like Lucene to maybe compute consistency, across runs, for outputs or something like that. Just, it's sort of an interesting idea, like can you repurpose some of the Elasticsearch built-ins to do some of this evaluation stuff?
Yes, definitely. So one of the reasons we use the out-of-the-box for now is because of the kind of built-in support with the agent framework. So I mentioned like LangGraph and Langsmith, but then we are able to build, store the data in Elasticsearch, like those traces in Elasticsearch. Like all we need is just like an additional visualization layer. So that is possible to build, and I would say we are building something like that. One interesting thing actually about working Elasticsearch is that like sometimes we'll have, because users can use Elasticsearch for like anything, right? Like that's how we had started to have the security kind of product, is because people were just using the raw Elasticsearch and they were building an entire cottage industry of security, like visualization layers, security, like threat hunting products on top of Elasticsearch. So then seeing that, we then started kind of making our own as well. So things like recommendations are the same. So I think with this, like as we see more use of people using Elastic Observability, we're able to kind of see whether it's needed to like build a out-of-the-box tool for users. So there is definitely like something like that planned, but I don't want to kind of like, announce or kind of share too much. But yeah, it is possible and people are doing it.
Cool.
Yeah.
Thank you.
Yep.
So,
Yep, you first and then.
so when you're using like LLM as a judge, do you generally like use models that are not like the primary LLM, like what to judge the model?
Yes and no. So I did mention there's a possible bias, but actually we try to calibrate the evaluation, so we note down that like this LLM as a judge is better or not. I do not want to explicitly recommend something because we have like an internal document that has like for this use case we qualitatively think that this model is better than other models as being a judge for this use case, like internally. I wouldn't say it's totally scientific. It is a little bit like qualitative, like we run some manually and then see. But yeah, I wouldn't say we totally just like don't use the same model at all, but rather we try to find the best evaluator model for that use case.
So it's kind of like another like grid search kind of situation where you try out different models and see which one.
Yes, yes,
Okay.
yeah, exactly.
And I was just wondering, was I next? I'm sorry.
Yeah, you
Okay.
and then this one, yeah.
I was just wondering if your team had looked at Inspect AI by any chance, which is a way to kind of pull together a bunch of evaluations, and it's fully in Python, and then does some nice reporting at the end of rolling that up.
We haven't, but I could look it up and see if it's a good fit for something that we're doing.
Cool.
Yeah.
Yeah, we're having some good luck with it, so it might be a good fit.
Okay, yeah, that's great to hear. I mean, it's good to learn about new things.
Inspect
Yeah,
AI
Inspect.ai?
comes out
Okay.
of UK.
Have you found that like in production, like online with LLM as a judge, you're really able to use that for like hallucinations and like when you don't have that golden data set to compare to? Or do you kind of have to go with like alternative approaches?
So it is possible for the LLM as a judge if you pass in like an example or two. Like you don't want to overload the context window though. So I found that like we can load in like some examples, but it's not super helpful all the time, but at least it does help a little bit with that. So I guess using like examples to try to help shape the behavior of the evaluator LLM. But other than that, I think there's some kind of like pros and cons of that as well, because you also don't want to have too many LLM as a judge like at the time of, or you might have to kind of rank the importance of the LLM like guardrails, so to speak, right? Because you might have limitations on how much you want the user to wait for generation and things like that. So I guess in short is that we try to do it and try to regenerate an answer based on that. But we also don't want to overload everything with like examples and then kind of increasing the compute time. So let's see. Yeah, so it's a trade-off. I wouldn't say we perfectly solved it.
Yeah.
Yeah, I don't know if that answers the question or not.
For your LLM judge, do you also like a score, confidence score, or you also provide output, have it ask, produce evaluation text? Then you have to kind of evaluate that evaluation content.
So we actually try to create like a just more like simplified labels, so like accurate or not accurate, or yes or no, or things like that. But you could have it reason as to why, but then use that more like as a supplementary information rather than like part of the later score. Yeah, so that's how we found it easier to simplify and understand. Yeah. Yep.
Thank you. So, sorry, I have never used either LensMeet or LangFuse before. So, just want to get probably general understanding, like it can detect whether you are calling the tool properly, or whether you are calling the correct tool.
No, we have to run have that in the evaluation itself or guardrail. So you mean like during live?
Yeah, well, the agent is running, right? So whether, like, let's say I have a multi-agent application, it has some orchestration, right? So, and then the first agent route the task to the agent B, and then, but whether this is a correct routing. And then agent B has several tools.
Yeah.
And it calls some tools, right? But whether that's the correct tool calling, whether that's the right choice. And even if you make the right choice, is it calling the tool successfully? So I don't know, like, which between LensMeet or LangFuse, which one can provide this kind of like visibility. And I don't know, like for this kind of evaluation, that means you also have to provide the ground truth of, okay, in this circumstance, route it this way, and then use this tool. So, but I just doubt that people are gonna provide that.
Yeah, I think it doesn't come out of the box, so at least, so the tracing will just tell you it picked this tool. But then
Yeah.
during development and live, you have to probably come up with your own logic as to
Yeah.
like, is
You
this
just
right
get
or
the
wrong?
tracing log, and then you have your own deterministic way to see
Yeah.
whether that's a right. So you still have to provide pretty much the ground truth
Yeah.
of the logical path.
Yeah, exactly. So some of it is a bit more ambiguous, and I would say, yeah, for the evaluation case, it is easier to do like a separate, like offline evaluation. You can run use cases
Yeah.
where you do have the kind of,
Or,
the known correct tool.
or use LLM-Judge to look at two
Yeah.
logs easier.
Yeah, so that is definitely possible too. Yeah, and of course, like when we're automating tools, kind of evaluations like that, we'll definitely like try to get a gut feeling, like by running it manually and see if your LLM as a judge is like correctly judging if the tool call is right before setting it loose on like a larger sample. Yeah.
I'm curious if like when your evaluation has found that the model isn't performing well, like what types of changes have you made? Like, is it just prompt tuning? Do you add other agents like in general? And this could be a whole other talk probably, but I'm just curious if what things have worked for, yeah.
One huge one we found was actually just, hallucination and false positives, for example, for the attack discovery. Like it would kind of find attacks when there weren't attacks. That's why we added more benign examples in the golden data set, and then we tried to do prompt tuning as well to be like, don't be too aggressive in finding attacks unless you're sure, or try to reason through it, having a more chain of thought and reasoning. Like if you're like analyze it and explain why you think there's an attack before writing out that there's an attack. So I think combination is adding more data points during development, as well as prompt tuning, as well as what was the last one I just said?
Chain of thought.
Yeah, exactly.
Is the golden data set part of the context that you would kind of pass in? It's like these are.
We wouldn't pass the whole
Oh.
thing. Only like we wouldn't pass the golden data set. Yeah, during the runtime.
Okay, that's just for evaluation.
Yeah.
Oh, okay.
Yeah. Like as I mentioned, during runtime, during live runs, you can pass in like one or two kind of like golden data samples, but you don't want to overload the context window and make every call like super having a lot of junk in it too. So that's what I mentioned, I guess, to earlier question, which is you can provide some examples to like shape the live results, but then when you're evaluating it like not in a live situation, then you can have the golden data set.
Mm-hmm.
Yep.
Kind of a follow-up question to that and my question before, like when evaluating offline outside of the golden data set, like do you have any specific approaches to try and get like to evaluate on something like factuality or like accuracy? Because like I've been working on something with my team that's like we've been struggling to kind of capture like how correct we are with the facts when we're outside of like our version of that golden data set.
Right. Can you explain more maybe like if it's like on different questions, how are you running the questions? How are you coming up with the questions for evaluating? Is it just like you're just typing in a conversation? Or?
Yeah. So like we're pulling in like we're outputting the same kind of like summary every time. Like our prompt is about like summarizing a bunch of data, but like that data can vary depending on like it's like a specific user that we're looking at. And so like because the data comes like from different users depending on like the run of like our like summary like agent, we are kind of struggling at like getting the accuracy or like factuality of like the user data in that summary. And so like we're evaluating the iterations on our golden data set, but then like outside of that, we're not as sure and we're just relying on like eyeballing.
Right.
Yeah.
are you able to just like for these kind of new kind of examples, like use any sort of like parsing type or I guess like what about like if you could summarize like I guess for example, like I had like a LLM-as-Judge like rubric which had different questions from different angles, all about something like very specific. Like, given this kind of context of this user, is the answer covering like what they have? Like you might hard code something that like pulls up their user attributes and then try to match it with that. So maybe like a mix of like you hard coded the database.
Like kind of like that rules-based approach where it's like a function instead. Yeah, that makes sense.
Yeah.
Yeah, that's an interesting idea.
Yeah. Like maybe it won't be able to do that like live, but at least it'll help you like, you know, run that offline.
Right.
Yeah.
Yeah.
With something you know is.
Because like live, there's more of that human in the loop, but like then there's potential for mistakes from like a human perspective.
Right.
But like that rules-based offline approach is interesting. Yeah.
Yeah. Or you might have to design your application in a way where the outputs are maybe more structured. I don't know if that's like desired or not, depending on the situation, but stuff like that where it might be easier to evaluate or kind of to ensure the behavior is more deterministic. Because for example, like for the, you can use like a tool actually to do that because, for example, for the chatbot, even though it can answer lots of things, if it detects that the user is doing the ESQL flow, it calls the ESQL tool. The ESQL tool has more definitions on how the output should look, which should look like an ESQL query.
Yeah.
Or if it's like a summary task, you should have, the tool would be more structured, like as in it knows the summary task should output it like this. So it's not like one size fits all, but rather defined in that like specific thing your chatbot is doing. So does it only do summaries or does it do different types of summaries? Are there ways you could smaller?
Because we do have a very consistent kind of summary of like data, and so like having that like maybe like regex or like structure like to kind of check.
Yeah.
That makes sense. Yeah.
Yeah. So depending on the situation, you could do that first, like on the offline evaluation. If it helps in your online outputs too, then you could you could do that too. But I guess it depends on the situation. But I think that would help with your offline evaluations for sure.
Cool. Thanks.
Yeah. Right.
Thanks for saying extra.
Yeah. No, of course. Happy to. I know I kind of went over a little bit with the.